Okay. Welcome back, everyone. Anyone? Yeah, day 15. Advent of Code. I forgot to. There. YouTube, it's so annoying. Like, I'm watching my own stream. Why does it have audio? Like, if I were to monitor my stream, I would at least monitor the output from OBS and not like the feed that goes halfway around the world before it gets to me. Anyways, yeah. So yesterday we figured out how to, what was it? Fly? Oh yeah, how to dock at the docks. Today it seems maybe we're going out to this island. It seems we have 2 more days up here before we might start going back down again. So that's interesting. Just before we get started today, I actually wanted to show my day 13. That's the one that I didn't finish on stream, and I realized I never sort of went back to it. So yeah, this was the one with the buses. The task here was simply to find the buses where there are like the first timestamp where the buses align, depending on their position in this list. So at their offset. I started doing some stuff, and then Pietro Pater, or how he pronounces that, came with an idea of like using higher index, or like trying to iterate the list of possible timestamps faster, and this is what I came up with. So basically, we start at the first bus, and we just have the step distance is the value of the first bus, because we know like the first bus has this cadence to it. So we can start looking at that, and then we can directly skip to this one because we know none of these will line up. So when we then find a bus that is at the correct index, we time our step distance by that bus, which means that this pattern will only appear at the multiple of these at that cadence. So it's this cadence times by this cadence gives us or the value gives us the cadence of this pattern, right? So that gives us that. Now we're looking for the next one, because we know when we step by this distance, they're always going to be in this position. So we just skip along for all of these until we find the next one in the right position, and then we do the same. We time that into our large factor here. So now we're looking at this pattern, the cadence of this pattern. So we just jump forward by this. And this number obviously grows pretty fast. So it runs really quickly. As you can see, it's pretty fast. Whereas the other one just didn't complete. Anyways, let's have a look at day 15. As you can see, I haven't opened anything. I haven't looked at it. So yeah, this will be interesting. And I had problems pronouncing initialization yesterday. Rambunctious recitation. You catch the airport shuttle and try to book a new flight to your vacation island. Due to the storm, all direct flights have been cancelled. Aha, that's why we weren't going directly back. But a route is available to get around the storm. You take it. While you wait for your flight, you decide to check in with the elves back at the North Pole. They're playing a memory game and are ever so excited to explain the rules. In this game, the players take turns saying numbers. I'm just hovering these now because of the fun joke from yesterday. They begin by taking turns reading from a list of starting numbers, my puzzle input. Then each turn consists of considering the most recently spoken number. If that was the first time the number has been spoken, the current player says 0. Otherwise, the number had been spoken before. The current player announces how many turns apart the number is from when it was previously spoken. Okay, so after the starting number, each turn results in that player speaking aloud either 0, if the last number is new, or an age, if the last number is repeated. For example, suppose the starting numbers are 0, 3, 6. So turn 1, this number is spoken, this number is spoken, this number is spoken for turn 1, 2, and 3. Turn 4, when was the last time 6 was spoken? It hasn't been spoken, or this was the first time it has been spoken. So that was the first, yeah, so then we say the number is 0, because it's the first time it's spoken. Next, again, consider the last number spoken, 0. It had been spoken before, it was the first number. It has an age of, I guess, 1, 2, 3. Since it had been spoken before, the next number to speak is the difference between the turn number when it was last spoken, the previous turn 4. Wait, 4? Oh, right, yeah, the fourth turn, yep. And the turn number of the time it was the most recently spoken before then, turn 1. Thus, the fifth number spoken is 3. 3 has also been spoken before on turns 5 and 2, so the sixth number spoken is 5 minus 2, 3. Since 3 was just spoken twice in a row, and the last 2 turns are 1 turn apart, the seventh number spoken is 1. So on and so forth. I'm not going to read through all this. The game ends when the elves get sick of playing or dinner is ready, whichever comes first. Their question for you is, what will be the 2020th number spoken? In the example above, the 2020th number spoken will be 436. Here are a few more examples. The 220th number spoken is this. Given your starting numbers, what will be the 2020th number spoken? And this is my puzzle input. First time this year it hasn't been a file. I think I'll actually put it in a file anyways. Just so it's easier for other people to swap that out if they want to try this themselves. So we basically need to keep the last time a number was seen. And I'm thinking we do this with a table because that makes the lookup really easy. We also want stereoutils to split that string on commas. So let's start with the starting numbers, which is, yeah, that also has parse utils. So we are going to read the file, and that was input.txt. We're going to split that on a comma, and then we are going to map parseInt over it. So now we have a sequence of numbers. Now we want to set up our table of numbers. So last seen is a table that maps from integer to integer. So from the number to the last turn it was seen. And then for number in starting numbers, we just want to put last seen number is equal to, and we're going to grab the index here, I plus 1. So that means that in this case, for example, 0 here will store the number in our table, will store the number 1. So the next time we see it, we can take this term minus the lookup from the table and get this. And of course, store the new one in the table. So now we want to do for I in, so I guess this will be the first like proper turn we'll take is turn 4. So we want to go from turn 4 to turn 20 inclusive. This is the inclusive version. This is the exclusive version. So for I in 2020, and now we are going to do if last seen dot has key I. So if we have seen this number before, then last seen wait. Okay, so if we don't have it, if we haven't seen it before, then we want to set this to last number is starting numbers 0. Yeah, so I is our turn counter. Oh, this should be the highest number. Right, so this should be our last number, not the turn counter. So if we don't have the last number seen, then we are going to say that the last number is 0. And we are going to store the last time this was seen as our turn counter. So in this example, so for turn 4, it was the first time 6 was spoken. So the fourth number spoken is 0. That means we store 0 in position 4. Ooh, no, wait. Yeah, we shouldn't do that. Don't store that, but the last number seen was 0. If we do have the key, then last number is equal to this turn minus the last time it was seen. So this turn minus the last time it was seen, and the last time it was seen is now, oh, we need to keep this. Oh, there should be number. Yeah, and we update that with the last seen counter being equal to this turn. And then on the 2020th turn, the number spoken is then stored in the last number. So we should be able to do that. Okay, map is from secutils, so we just need to grab that. There we go. And to try this out, we can do starting numbers is the test here, and do the same transformation as we tried to do up there, or as we did up there. And now running this should give us not the correct number. this should be 436 and not 2. So we did something wrong here. Last seen, these are all, so that stores 1, 2, and 3 for these numbers. We're going to say, so let's do these turns here. So from 4 to 10, and then just echo out the number we say each turn. And let's also just echo out the turn number. Right. So on turn 4, number spoken 6. That was the first time the number had been spoken. Oh, right. We shouldn't initialize this at all, actually. Wait, we should. We should only do this for the 2 first ones. And this should be turn 3. No. This should be turn 4, right? Yeah, so turn 4, that was the first time it had been spoken. The 4th number spoken is 4. Correct? 5, next thing, consider the last number spoken 0. It had been spoken before. So it should be turn 4 minus turn 1, which should be 3. It is 4. I'm guessing then we have a calculation error here. We are already, well, I can just say at turn I, last seen, turn last seen, last number. You can just also print out last number here. Oops, that comma was supposed to go out there. Let's see. So 0 at turn 5, last seen 1. Oh, right. Because we're looking at the previous turn, not this turn. Yeah, so 5 is 3. 6, last number spoken 3 has also been spoken before, most recently blah blah. 3. So 3, 0 for turn 7. That's 1. It was spoken 2 times in a row, and the last 2 turns are 1 turn apart. The 7th number spoken is 1. We see 3 at turn 7. Last seen at turn 6. We shouldn't store them. We shouldn't store it here until the next turn. Wait, should we do... I'm doing something wrong here. let's see. First number spoken. So we speak these three numbers and we store the last time we saw them. 6, that was the first time it had been spoken. So after the turn has passed, we need to store the last number. And let me do this. And this should be using number, and we should say number. I mean, these should be equal, so it doesn't matter terribly much. Number, and then store that, and then say last number as number, and we speak this number, right? 0 at turn 5, last seen at position 1, so that's 3. 3 at turn 6, last seen 2. Yeah, 3, 3. 1 for turn 7. I think that's the wrong. We find a 3 at turn 7, which shouldn't be last seen 6. It should be last seen 5. So we come in here. Consider, when do we store the second 3? We store the second 3 on turn 5. And then this is also 3. I'm just doing something dumb here. I'm pretty sure. Yeah, so 4 at turn 0, 0 at turn 5. Last seen on the first turn, that's 3. After that, let's just echo out everything we do. So we do this, echo number, turn I, and then just print out not seen before. Let's just, yeah, that's a number we are speaking this turn. And then setting last seen for, oh right, because now we're storing them here, it should be -1. Because we saw them last turn, not this turn. 0, 3, 3, 1, 0, 4. 3, 3, 1, 0, 4, 0, 4, 0. Yeah, that's right. Now it should work. I was just storing them too early. Yeah, 436. Do we don't really need to test these, do we? 3, 1, 2. Test this one. 4312 was it? Yeah. 1836. Yeah, that seems fine. Let's just run that with our input. Oh, invalid integer 5. Right. So the reason why that happened is that the last thing in that file is a new line character. So if we just say everything but the last character, we drop the new line there. There we go. 1056 should be our answer. Oh. Did we by accident strip off too much? Or do we actually have an error? It's 15 today, right? Yeah. I'm just gonna try to put this, oops, don't do that. Double check that it's the right numbers, 43, 1, yeah. And we are just gonna input them here instead of in that other file, or instead of doing it through the file, because this seemed to work. Oh wait, silly me. Yeah, sure, we can keep that. We just looped. I wrote all of this with the expectation that that they were all going to be 3 numbers long. There we go. That should be our number. That's better. Yeah, so I had just written, I had hard-coded 4 and 1 in here, which was, this should have been anything but the last one, and this should start after the highest one. So that was my mistake. Impressed, the elves issue you a challenge. Determine the 30 millionth number spoken. For example, given the same starting numbers as above, the 30 millionth number spoken is blah blah blah. I think our solution should be fast enough to do that. I mean, if not, I'm not quite sure how we're gonna optimize this further. Oh, wait. I guess that was more to like take people who had, maybe I shouldn't say that until I have actually run and tested this, but I think that might have been just to trip up people who, it was 30 million, right? Yeah. Part 2. Nope. Ah, so this seems like it might be too slow. Oh, maybe not. No. Well, that was easy. Yeah, that's day 15 for you. Yeah, as I started saying, I'm guessing this thing was just to trip up people who had actually been storing them in a well, thank you. Yeah, I think that was just to trip up people who had stored them in a sequence or something and were actually like looping back through their lists to find the numbers. Um, but yeah, that would be a silly way of doing it. It's an interesting and not very well known sequence. What do you mean? Oh, like a numerical sequence thing? Right. Yeah, this haven't been seen before. This had been seen 2 places before. Right. The name FunX sequence is due to NJA Sloan. But NJA Sloan isn't named FunX, is he? Neil James Alexander Sloan. Wait, what? Oh, NJA Sloan named it the FunX sequence, not FunX himself, I guess. Sure. Oh, sorry, that's small for you. I keep forgetting. But yeah. Yeah, it starts with a yeah. Well, I mean, the sequence might not be very well known, but this is pretty easy to like this solution was sort of what immediately came to mind when I looked at this. That's actually a thing I've been thinking about. Like, as an extra credit for these, maybe there should be a like figure out how I made the data set, because for some of these, like, I guess for these one is you can just random generate stuff. But for I think it's this one. Yeah, for this one, I've been scratching my head trying to figure out how he makes the input. Like how does he make this input and make sure that there exists a solution for it? Or is it just guaranteed that they all will have a solution? No, they can't. Like if you have a 5 and a 10, for example, that won't have a solution. They are prime. Oh, wait, do they have to be actually prime or just what's the name for that in English? Like prime like in each other co-prime, yeah. Thanks. Yeah, so they could just be co-prime, right? It's just that they can't have the same like face. They can't, well, they can't have a factor, which would cause them to have the same face. Did he actually, like, I saw people talking about, yeah, I saw people talking about this yesterday, that they were prime, and I was like, well, it never specified. Like, could I theoretically get one that wasn't prime? But I guess this might not have worked. Oh, a sieving algorithm. Like, Eratos sieve for, or whatever that thing is called. Day 15. Ah, yeah, that's today. Oh, wow. Constant input. Ah, pre-parsing it, you cheat. Is that the one I'm thinking of? Some Greek names, Sev. Eratosthenes? I can't pronounce that. Input last turn. Right. Number and input. Yeah, basically do what I was doing. Wait, what on earth is... Oh, you're collecting init table. Ooh. That's pretty cool. Yeah, it's a while true with a turn instead of my for loop. If the turn is equal to target... Oh, right, and the target is... Right. If last not in scene... Yeah. Yeah, not in instead of has key. Yeah. Yeah, so I just put this outside. Oops. I didn't mean to actually move that. I'm not used to being in an editor that actually reacts to mouse presses. Yeah, so you just move that. I just moved this outside since it happens for both branches. But it's pretty much the same solution. Like I don't keep a turn counter, or I keep a turn counter by a for loop instead of a while loop with a turn and a early return thing. Yeah. Yeah. I know what it's for. But so wait, the search of the solution may be without loss of generality. I should zoom in on this for you guys. Oops. Where did it go? Surprise setting. There. Everyone else case it was supposed to Right. But isn't the values of these numbers modulo and 2 when I should find the solution? My brain kind of blanks when it sees math speak like this. Like I probably understand what it's trying to say. I'm just math terms. These are first the numbers that are congruent, modulo 4 to 4 modulo 5. For each of them, compute the remainder. Right. Yeah. My day 13? Or Pietro Pater's day 13? Wait, was day 13 the one where I cheated? No. This was the one I showed in the beginning. Yeah, that was the one I showed at the beginning of the stream. Yeah, so basically I start at the first bus. Step distance is that bus. Let me pull up the day 13. Yeah, so I take the first bus and I step in increments of that bus until I find the second one at the correct position. So where this is 0. Then I just increase the step distance to be the multiple of these two, because that's the phase which these will be in. The cadence of this pattern will be the multiplication of these two, because they are coprime. And then I increase the current bus. So I just start looking for the next bus, because I know, like, I don't have to check all the buses for every step, because I know that this is the cadence of this pattern. So I'm only ever looking at the next bus, because I know the cadence I'm walking with gives me the correct pattern for all the previous ones. And then I just do that for all the buses. And the position we would start looking for the next bus when there are no more buses is the position where all the buses match. Yeah. So this was yours. Why are yours always so much longer than mine? I mean, my solution 2 ends here. Well, I guess you have both in one file. For other days with tricky initial conditions, Eric mentioned the day with the seating area to be tricky to generate. Both parts in one file. It took a bit to come up with the initial condition generator would generate inputs that both look somewhat like seating area and also have interesting behavior. That was for day 11. That was the seating thing. Day 11. Well, I can have a look at part 1. Yeah, this really reminded me of like Game of Life, which I've luckily programmed before in a couple of different versions. So this was a pretty easy one for me because I've done it before, just with different rules. So yeah, and I guess you notice in this one that he realized, or he was probably aware of it before he started, but he updates the rules. No rules for blah blah. He updates the rules here. Where he say that they can see more people. And that is, yeah, it's the 8 occupied seats. Oh no, wait. People don't just care about the Jason and blah blah blah. For example, yeah, also people seem to be more tolerant than they're expecting. Now it takes 5 or more. So that was the one. Like that's the thing when I was implementing Game of Life a long time ago. That's like the one thing that you start doing is like, what happens if I tweak the rules? And in Game of Life, it pretty much means everything dies or everything comes alive pretty quickly. It's a really well balanced little thing. Like you can't change any of the parameters pretty much. Yeah. Oh wait, that worked. I guess you also maybe put a bit more new line in your 28. And that was for, what day is this? This was the buses one. Which was day 13. Part 2, right? Yeah. Mine is 31. Well, I have comments in my... That doesn't count. So subtract at least 6 lines. So 25? Yeah. Still a bit shorter than you. But I don't have barely any white space apart from the comments. Oh. Why do you do that? Discard. Oh, right, because the first line didn't matter for this one. Right. Wait, but you only parse... Oh, you add them as a 1. Wait, what? You add them as a 1? Oh, because that means they will only be 1 more than... Yeah, right. Only needed the second line. Yeah. But you're not multiplying, you're adding it. Oh, no, wait. It's the modulo. Right. Yeah. Yeah. And yeah, multiplying by 1 doesn't matter. Yeah, I guess that makes sense. I just didn't add those at all. Like I parsed it into a tuple of the index and the bus. So I didn't consider those at all when I was doing mine. Block valid. Break valid. You like your while true loops. I prefer to have actual... Yeah, it's gonna be faster, but it's gonna be one iteration of this loop faster. Like this is gonna immediately hit. So it's just gonna be one tiny loop. Yeah. Yeah, these... I mean, has to be super confusing for the people watching on Twitch who aren't looking at the IRC stream. Yeah, I can agree with the while true increment cursor thing, but I usually like refactor that afterwards. Yeah, or the people in Discord. Yeah, either people watching the stream without watching IRC, or the IRC people. Yeah. Yeah, I mean, you could chat in the Twitch chat. Or the YouTube chat, I guess. Which I'm not really watching. Oh, you have... Yeah. I check YouTube chat. No, I check Twitch chat. But I don't typically check the YouTube chat. Just because I can only have one chat window open at a time. And previously, people have mostly spoken on Twitch. Wait, were those comments on me sitting there trying to think of ways, or... I already have 3 monitors. I mean, I have 2 more monitors in the basement, so I could set up 5 monitors, but I could also just like side by side them on my side monitor. Yeah, so when you're running oh, no, in day 13. Day 15. Yeah, running this took just so long that I was about to like, crap, I need to optimize this somehow. I need to find a smart algorithm. I mean, I guess this bring our time down a bit. That shouldn't matter. Like the garbage collector shouldn't matter. part 2. Eh. 2.2 seconds. Wait, would that actually give me a speed up? SC FLTO. FLTO is just like faster math operations, isn't it? Like faster floating point or something. Yeah, doesn't speed it up. Or, well, maybe a little bit. But why isn't that the default, to be honest? Like, does it have some penalty in other scenarios? Okay, it is slightly faster. Not much, though. But yeah, as I said, I'm pretty sure that part 2 today was basically just to mess with people who actually stored all of this stuff in a sequence. And then like looped backwards through the sequence to find their answers. Yeah. I mean, for someone using Python, I think this would still be. Would this still be painfully slow? Like even this fast solution? Because it's this slow in Nim. Oh, I should change my part 2 to do this thing. Check that I get the right number, and I don't, because I don't strip off that new line at the end of the file. And there we go. This should be what, 1065? This took more than 2 seconds. Oh, I'm not compiled in release mode. Right. Oops. Well, that's not very useful, is it? Yeah. And day 15. And let's push this. But yeah, that was day 15. Pretty easy one this time. Oops. Yeah, as I said, pretty easy one. At least since we did it sort of right the first time. Probably gonna stream tomorrow as well. I kind of like doing these. It's kind of fun to follow this story along as well. So now we're going, flying off to this island. And we have 2 more days up here before we go down again, it seems. So yeah. I wrote a post earlier today on my website about this video content that I've been putting out since I haven't posted anything here since June. I write here that I'm working on my keyboard, the split keyboard that I don't have right here right now, hand soldered thing, and I hope to write the firmware for that in Nim. So I might put out maybe some videos, maybe some articles on how to do Nim programming on microcontrollers, stuff like that, which should hopefully be interesting. But that's everything for me today. Hope you found it interesting, even though it was an easy one. And yeah, continue having a Merry Christmas, or a Merry Advent, at least for the time being. Yeah. Goodbye.